Okay, so here we're told that the perimeter of a rhombus, MATH, or math, is 40 centimeters, and the length of one of the diagonals is 6 centimeters. What is the number of square centimeters in the area of rhombus, MATH? So square centimeters, they want us to find the area of the rhombus. And a rhombus is a parallelogram, of course, where each side is exactly the same length. It's as if you took a square and just kind of tilted it, right? So each side is exactly the same, and the diagonals have some great features as well. They cross each other at right angles. So these are the diagonals, right? Connecting opposite points. They cross each other at right angles, so that means they form 4 right triangles here. Right triangle, a right triangle, a right triangle, and a right triangle. And furthermore, they not only perpendicular to each other, but they bisect each other. So each of these segments are exactly half of the total length, or they're equal to each other. And then just recapping again, each side out here is equal. Like you took a square and kind of tilted it. So when they tell you that the perimeter, right, is equal to 40, since each side is equal, you can take 40 and divide it by 4, and that gives you 10. And 10 is the length, right, of each side, and then I'll write in parentheses, or hypotenuse, because those sides are the hypotenuses of the right triangles that we have, right? Now they're each 10. Also, the diagonal itself, one of them is 6 centimeters. So here, let's say this one is 6. Well, that means that these line segments here are each what? Well, if they bisect each other, or cut each other in half, that means that these are each equal to 3, right? And now what I have is a right triangle where the short leg is 3 and the other leg is unknown. And that other leg is the height of each triangle. Now each of these triangles are identical, right? They each have the same hypotenuse and the same shorter leg. So they are all congruent. If we solve the area of one, we can quadruple that or multiply it by 4 and get the area of the full shape. So I'm going to use the Pythagorean theorem, right? A squared plus b squared equals c squared. And here we'll say a squared equals 3 squared plus b squared, that's unknown. Our hypotenuse, or c squared, is 10 squared. So that's 100. And 3 squared, of course, is 9. So 9 plus b squared equals 100. And solving for b squared, we get b squared equals 100 minus 9, which equals 91. And b squared equals 91. Take the square root. B equals the square root of 91. And here, we're not going to break it down any further, but that tells us the height of the triangle. Right? Each of these are radical 91 and radical 91 over here as well. So now, to find the area of the full shape, find the area of one triangle. So find the area of a triangle. We get 3 times radical 91, and then we cut it in half. And this is the area of one triangle, but we have 4 of them that make the rhombus. So that's the area of one triangle. And so we take this 3 times radical 91 over 2 and multiply it by 4, right? Because this happens 4 times. And one nice thing that will happen is that 4 over 2 is just equal to 2, right? And then here we have 2 times 3, which is 6, radical 91 square centimeters. This would be the area of this rhombus. So the strategy we could use here is to find the area of one triangle and multiply it by 4 to find the area of the whole rhombus. All right, thanks.